Cyber threat intelligence is knowledge, skill, and experience-based information concerning the occurrence and assessment of both cyber and physical threats and threat actors that are intended to help mitigate potential attacks and harmful events occurring in cyberspace. Cyber threat intelligence sources include open source intelligence, social media intelligence, human intelligence, technical intelligence, device log files, forensically acquired data or intelligence from the internet traffic, and data derived from the deep and dark web. Sorry, that's a long definition that nobody understands. But in general, it's about collection data and threats and using those threats to protect ourselves. Right? One example is I went to a talk by a guy from Rapid7 a couple of weeks ago, and he said that, well, Rapid7 is this vulnerability scanner, and vulnerability scanners basically searches the network to find what you have installed and what versions of them, and that tells you what needs to be patched, right? And they are using CGI in that they are looking on the internet and seeing which exploits are being exploited, or which vulnerabilities are being exploited by the bad guys out there, and then when they finish the report of the vulnerabilities, they prioritize those that are actively being exploited on the internet, because obviously that's more important to patch than those that aren't. That is one way to use CGI. Or if you're using like a Cisco product like Cisco SecureX that blocks egress connections to command and control servers, because it's being collected by Cisco's CTI team, which IPs are command and control servers, so you block access to those so that people on the internet, on the network that's being protected by Cisco can contact these. Right? That's another example. And what CrowdSec does is much more simple than that. That's called IP reputation. Basically, we are building a big database of IP numbers, and we tell them, and if they're bad, we mark them as such, and also a little bit about what they're doing. That's but the bottom line is that CGI is just like the word cyber itself. It's a word that we use all the time, and nobody is completely sure of what it means. But CGI is this big, hat of things that you, as I said before, you collect data and you use those informations. But there are like a myriads of ways to do it. So CGI is not just CGI, it's much more than that. All right, I hope that helped a little bit. Yeah, these next minutes will be about how CrowdSec works, the architecture of CrowdSec, and it's also the CrowdSec consensus engine, and it's not exactly a talk about how CrowdSec works and what it is. In that sense, I did a talk at BSides London last year that's 45 minutes just about CrowdSec if you really want to dig more into it. But I'll just tell you the basic, and then we should get hands-on, because listening to me just talking, will bore you to tears, I guess. You may have heard about a tool called the fail-to-ban. Fail-to-ban is a fantastic tool that was invented 20 years ago that is able to read your log files and detect brute force attacks. And when it does that, it will simply block those brute force attacks. As I said, it's great, but it's a bit old in the sense that, as I said, it was invented 20 years ago. It's written in Python by a guy trying to learn Python. So, there are also some performance issues, and also each installation it's not aware of anything else. So our founders had a secure hosting company, and they were using fail-to-ban, but they thought, hey, can't we improve this somehow? And so the idea was basically to let people help each other fighting the bad guys. I guess that's the marketing term. But so to some degree, we have been marketing CrowdSec as something that's like a fail-to-ban version 2.0 or fail-to-ban on speed or whatever. And that's not completely true. It's also not a lie, because yes, CrowdSec can also detect brute force attacks, but CrowdSec can do so much more than just that. In reality, it's a rule-based framework that can detect anomalies of any kind. Everything is set up in YAML files and grok files to parse the log, so it's it's easy to mess with in that sense. But in terms of deviations and what attack CrowdSec can detect, it can detect a lot of things going on layer 7, like layer 7 DDoS or credit card stuffing. Credit card stuffing is when you buy credit card information in bulk by hackers and you want to see if they work. Then you fire off thousands of transactions on an e-commerce site in small amounts. Obviously, that is an uncommon way to use a website. So that's an obvious thing to detect. And also bot scraping can detect that bots that are scraping your website if you don't want that. And a lot of other things like data filtration from an S3 bucket in AWS. So I said AWS, yeah. And also in terms of DDoS, we have a bouncer, the IPS part of CrowdSec, that integrates into Cloudflare, so that you can block DDoS attacks on the free tier of Cloudflare using CrowdSec as well, or Fastly. That's another CDN provider if you don't know it. Also, as we'll see later, CrowdSec doesn't just block traffic. We'll be using CAPTCHA within NGINX. So, and NGINX is important. CAPTCHA is important because there are options, or there are situations when we don't want to block anything, because we have an e-commerce site, and blocking users means saying no to money, and we are not too happy with that, because with all the IPv4 shortage that's going on with netting all around the internet, you can end up having the same IP, having the same ban IP as a bad guy that's in our database, and then it's a little bit of tough luck. But hopefully somebody is using like a CAPTCHA solution rather than blocking you. But we don't know. The way CrowdSec works, just like fails to ban, it reads logs, right? And CrowdSec supports like syslog, the AWS CloudTrail, Kinesis, Docker, log, and Windows Event log, and also normal log files. The CrowdSec agent passes those log files, it detects threats, and it gets a block list from the common CrowdSec servers. Then the bouncer remediates those threats and then share the data to our consensus engine, which I will talk about a little bit later. That's our mechanism we have that tries to figure out which of all the signals that are being sent are actually, in the end of the day, a bad guy doing bad stuff. And then when it has done that, it will detect, or it will send the IPs that are blocks that are actually bad IPs back. Right. Yeah, there was a sound issue on the stream, and it's fixed now. Yeah, the whole data sharing part that can be disabled if you want to, but of course, please don't. The way it works is that CrowdSec offers like a free open source software that you can use and share the information about the attacks you see, and in return you will get the information from everyone else. But if you disable sharing, then you won't. You will still have the mechanism that's able to detect attacks locally, but not the block list. CrowdSec is API driven. That means that all components in CrowdSec communicate using REST API, so it can be distributed. That means that if you have a large parameter with a lot of firewalls where you want to parse logs, you can do that on different instances of CrowdSec and then make them all talk together via one local API that's talking to the CrowdSec data lake on the internet. Or you can have it just on one server if you're just a simple quote unquote a self-host are using it at home. That's also possible, of course. That's the beauty of open source, that you can use it whenever you want to. But as we can see on the diagram there, on the left part, data sources are being parsed. Then you can see the way they are being parsed, and data moves throughout the application when behavior is detected. And the CSCLI, that's the command line interface of CrowdSec, is also integrating and talking to the data via REST API. Also, it's possible to send a notification whenever you get something blocked. That's also API. The bouncers are talking using API. So yeah, in that sense, it's very flexible. Yeah, the CrowdSec also supports Helm, Docker, Kubernetes, stuff like that. So in that sense, it's also very DevOps friendly, which I guess people here would appreciate. And yeah, I'll talk a little bit more about that. For instance, where it runs. We are mostly Linux geeks, so Linux in all flavors are supported, both on Intel and on ARM. We also have a Windows version, not that advanced, but it works. We also support BSD, FreeBSD and OpenSense, and hopefully soon-ish PFSense, but I can't say anything about when. And then, as I said before, Helm, Docker, and Kubernetes, Helm charts, and Kubernetes and Docker, sorry. In terms of bouncing, sure. The question was, why did we choose to prioritize OpenSense? That was because that decision was made back when there was a lot of talk about PFSense licensing, and it looked like they were getting a lot of bad publicity on that, and OpenSense seemed to grow better. So that seemed to be a better choice at the time. But then after that, we found out that a lot of people are using PFSense, and they really want CrowdSec. But there is a French guy who had wrote a blog post a couple of, I think last month or so, on how to get it running on PFSense, so that you can do something on PFSense at least. In terms of bouncing, we also support AWS WAF, so that CrowdSec can hook into that. And also on network level, on each Linux and BSD and Windows, CrowdSec of course hooks into the local host firewalls. We're also talking to providers of BDP block lists about contributing IP to their block list, because the whole vision, one of the visions with CrowdSec is to detect attacks in real time on the internet and block them in real time. And if we can block the bad guys on BDP router level, BDP is this protocol that ISPs are using to route between them. That would basically mean cutting them off at the source, and that would be great because they need to die, obviously. CrowdSec can also bounce on servers, NGINX traffic, Caddy, HA proxy, and a few more. These are just examples. And even if you have an application in PHP, in Python, in Go, or in JavaScript, then you can also include CrowdSec protection inside the application just by adding a simple line. So yeah, there's a lot of opportunities to mitigate threats. In terms of running serverless, we support AWS best because we use AWS ourselves. So CloudTrails and Kinesis are supported as log sources. AWS WAF is supported as bouncer, and then of course you can run it in on Kubernetes in a pod there. And Windows, it was recently released. There is a relatively small list of parser scenarios and bouncers. There's only one bouncer. That's the Windows Firewall bouncer. But by default, it can detect everything brute force attack in Windows outlogs and event logs. And so remote desktop brute force, SMB brute force, MS SQL, Exchange, stuff like that is supported, and a few other things, IIS as well. Yeah. In terms of how this whole consensus thing works, one of the questions that I'm asked a lot is how do we deal with poisoning and false positives, because that is a good question. Because obviously, and also as I said before, this whole block list is being distributed among agents, no questions asked. So we can't have any false positives, any bad things on that block list. That is very, very important. So the way it works is that every time a new CrowdSec agent starts sending data, it will have a trust rank of 0. And then over time, that trust rank will build. So that means that in like 6 months' time, if you've been totally reliable sending signals to us, then you will have a trust rank of 99. And that trust rank is being used whenever the consensus engine is trying to figure out whether an IP is bad. It simply asks, do you know this IP, or who knows this IP? And then the agents that knows this IP, they are voting with the trust rank, meaning that if you have a high trust rank, then you can affect the voting process. But getting a high trust rank takes time, and that's that's basically the reason why we have this mechanism, because we don't want bad guys to come in and poison the database just like that. It needs to be really, really cumbersome to do that. And on top of that, in this voting process, each ASN only has 1 vote. So that means that not only does it take a long time to get the trust rank you need in order to support, in order to affect the voting process, you also need to have all your agents on a large number of ASNs around the world, else you won't have enough voting power. So it is at some point going to be. Right now it's not, no. But that is an ongoing discussion. We want to be transparent about it, but the way the consensus is built up now is very much, spaghettied into our own infrastructure code. So we can't, just separate it. But we want to share it, but there is no date on how to do it. But we are asked about it frequently. And as I said, it's not because we don't want to. We want to be transparent. In terms of false positives, we have our own little fleet of honeypots. They have a slightly higher trust rank, and they are being used to assess community signals. So basically testing them and see if they're good. There are IPs that we don't want to block: Google DNS, Cloudflare CDN, all sorts of things. So that's not possible because we have this huge whitelist. And then we have like a predictive algorithm trying to figure out which IPs are bad before they do something, or we detect it really fast by that is based on their environment and like characteristics we know of that IP. If we have some CTI, some CTI about the IP that maybe it's exposing vulnerable services, then there is a high probability that it's being compromised and being used by a malevolent actor. So that could fast track an IP into the fire database. Something like that we are trying to use. We just hired an AI guy to implement stuff like that. And then, the consensus engine is putting the bad IPs into the fire database, and then that is being distributed as block lists. It's a very simple overview. The point is that is the bouncer asking the agent when he sees a new IP. Then the bouncer asks the agent whether this IP is bad or not, and not the other way around.
Sorry. What you showed in the previous slide, the hoverboard whitelist, and the operator is the only one within the agent.
So which this one?
Yes. So the 3 blobs at the top, hoverboard whitelist, and the algorithm, they all run and stored within the agent.
No. Well, the question was whether these 3 honeypots, whitelist, and predictive algorithm are stored within the agent. No, that's happening on the back end.
That's central. Shared file agents.
Yeah. That is within the consensus process that happens back end. That is a code that we at some point are going to be more transparent about.
But every agent must keep a whitelist and a blacklist as well.
Yeah, it's also possible to define something like that on the agent. But there's a difference between what the agent decides to block locally and what is being sent and what is being blocked globally. Those are two different things. Yep. In terms of observability, we want to know what's going on with the CrowdSec, and we like fancy graphs because we're geeks, and so we have, of course, possibilities for that. It's possible to do something with Grafana based on local Prometheus endpoint. I won't be covering that today because that's a little bit cumbersome to set up.
And you have it tomorrow?
No.
No?
Not tomorrow. Oh. But I actually, to be honest, I don't really know that much about Grafana. I haven't played around with it that much. Then in terms of the CSCLI, we can also do some observability within that. Data actually also comes from the local Prometheus service, but it doesn't really matter. You don't care about that as a user. You just see the data coming. You don't really care where they come from.
Sorry, there's the meetup. Just I don't know if you confuse anyone, but happened tomorrow is a meetup for Arne and CrowdSec with you and Stefan.
Yeah, but I don't have anything to do with the Grafana part.
Yeah, okay, yeah, yeah, of course.
that is. I see that. No, but I didn't have anything to do with the Grafana talk tomorrow. That is purely coincidental. There is an open source project called Metabase which can create fancy graphs. We have built that into CrowdSec, so you can start that up yourself and run it. And then there's of course the console that I will also show you later. I'm soon finished talking, so just bear with me a little bit longer. In terms of important configuration files, there is the acquisition YAML file. This is where you define all data sources and types. So if you don't have your data source in here, it's not going to get parsed and you're not going to get anything out of it. So that is the really key file you have to know here. And then in terms of bounces, there's config file for each in the bounces directory. And then we'll be looking a bit more at the profiles YAML file, because this is where we'll decide which attacks triggers which remediation and for how long. And so we'll be configuring that a little bit later. And in terms of log file, there's the CrowdSec log file where the agent logs, that's pretty human readable and easy to understand. And also each bouncer has a log. Then the last text slide. Signal. Those are local information on a given attack that we're sending out. LAPI is a local API that's used to control your local the element of your local CrowdSec stack. CAPI is a central API where CrowdSec gets block lists from the community and sends signals to the Smoke database. JAgent does all the log parsing, controlling bouncers and communicating with the CAPI. The bouncer is the IPS part of CrowdSec. That's the one that mitigates the risk. So if you don't have any bouncers installed, you can't mitigate anything. You just have an agent detecting attacks and nothing happens there. That becomes boring very fast. In CrowdSec taxonomy, we also talk about a parser, and a parser is, as the name suggests, a log parser that tells CrowdSec how a certain log file is parsed. It consists of YAML and grok. So when you have a log file in a certain format, you will write grok to parse it and then put it into a YAML file, and then CrowdSec knows how to parse it. Scenarios, that's what comes after the parsing file, the parser file, where it's defined which attack or which situation we want to react upon. For instance, there's a scenario for SSH brute forcing, where it's defined how many attacks in how many period of time, how many logins, and in what period of time do we need until we think it's a brute force attack. something like that.
And it can be customized.
Yes, that can also be customized. Yeah, I'm also working on a CrowdSec on a workshop on how to create your own parsers and scenarios, because obviously that's, first of all, it's really easy especially if you know how, and secondly, it's important for us to have scenarios and parsers, because the more that's supported, the more people use it. So that makes sense. Collection is a collection of parsers or just or scenarios. I think the only collection we have that's only scenarios is called HTTP-CV, which is a collection of scenarios that detects common web attacks or web vulnerabilities. The exploitation of certain web vulnerabilities is being detected by the HTTP-CV collection. A post overflow is the action to execute when a given scenario is being triggered. For instance, there's a post overflow called geo-IP enriching, because when we look up an IP, we want to know more about it, which ASN does it belong to, which country is it from. That's a post overflow that does that. Decision, that is what is being generated when a given scenario has been triggered. Oh, sorry, that was wrong. A decision is that is what is generated when a scenario is triggered. Sorry, and then the alert is a decision. Is what decision turns into afterwards, because it's the alert that defines the punishment for that IP. Or is it being banned? Is it being are we forcing the user to go through CAPTCHA for a long time and stuff like that? All right. I hope you're still awake, because now the fun begins. I prepared a bunch of VPSs, and I don't know how to do it practically, because we should each of you should have one, and it's all on that list there, and they're all numbered. So I guess that I will give a number to each of those that are present. How many is that? How many is that?
It's 20. Not joking.
Here?
With you, it's 21.
Oh well, that well.
Because here are online there are 7, and here are 13.
Yeah, and I created 20 just by odd chance. All right, first of all I'll assign a number to the people here, and then the rest can we'll see what we do with the rest. 1, 2, 3, 4, 5, 6, 7. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right.
Okay. So I will continue with 12 online.
Okay, cool. So Malte is my assistant and assigning numbers to the rest. All right, that's cool. Sorry. All right. As I said, you need something with an SSH client to be installed for this workshop. On the spreadsheet, you have 2 IPs and a domain name. The domain name, don't think about the domain name for now, but you will have a defender IP and you will have an attacker IP. And the defender is a Debian Linux. This is where you will be installing the CrowdSec agent and the bouncers. And the attacker is, as the name suggests, the attacker, that's a Kali Linux that we will be attacking the defender with, and then things might blow up or not. We'll see. The username for both your VPSs is workshop. It's just workshop, not more than that. Not a number, not anything. And I say it very thoroughly because someone always thinks it's workshop a number, but that's not the case. It's just workshop. And then the password is loudgoose90 for both. And when you log on to the VPSs, the first time you'll be forced to do a password change. And then after the change, you will be disconnected and you need to log on again with your new password. And if you don't get a password change, then something has gone wrong with all the the assigning of IPs. So we'll take it from there. Please find both your IPs and log onto both VPSs to verify that it works. And let me know when you've done that.
And logging means using the browser, or does it mean using SSH?
Logging in means SSH. Yeah, sorry. Not being totally totally transparent about that. But yeah, that was the idea. I'll just be talking a little bit while you verify that everything works. In terms of installing the agent, you will need to add our repo, and obviously just downloading a random script from the internet and executing with root permissions is not something I'll generally recommend. But for testing purposes, it works. We have Ansible playbooks. That's better. Yeah, and then after adding the repo, and this is where you need the slides set. The slides are open in the tab in your browser, because you don't want to just write that off. It's also available on doc.crowdsec.net, our documentation site. Yes.
From where I do get the slides?
That is. Yeah, I will find the slide and paste them in the channel where the. Yeah, there it is. bit.ly/CrowdSec slides.
Just a clarification, installation should be on the Defender.
Yes, installation should be on the Defender. You will find out fast if you did it on the wrong one, because Kali is not supported. So it will complain about things. Melda, are we helping Gunther? Malte?
Sorry?
Are you helping Gunther?
Oh, am I helping Gunther?
Yeah.
Of course.
Thanks. He needs IPs.
Sorry, I was totally
focused. You were hyper focused. That's good. Yeah. Once you have. All right. Well, if someone changed your password, then take a new one. I guess 19 and 20 is still available.
No, 19 is mine.
Oh, sorry, 20 is still available. The reason why we first installed the agent and then installed the bouncers, because separately, is because if you do just in one command, then you can control the order of installations, and we want the agent to be installed first, because then the bouncers will be automatically added. That will be easier for us. There's both an IP tables and an NF table based firewall bouncer. If you don't run any, it doesn't really matter. And if you do run like an NF table firewall, you would probably want to run also the NF table bouncer. Yeah.
So just CrowdSec is the agent.
Yeah.
And there's also always a one-to-one relationship between the agent and the bouncer?
No, not necessarily.
So those two bouncers could access the same agent?
They could, or yeah. Well, a bouncer needs to access one agent, but it doesn't have to be a different agent. That's that's what I said before on the API part, that you can set up one API endpoint that talks to all the bouncers, but that it doesn't have to be the same ones that are passing logs, for instance. So yeah. So how's it going? Any problems? Nope. All right, cool. Once you are installing the agent, you will see a bunch of things that looks a little bit like errors, but they're not. They are warnings, and just ignore it. The lines I've put in bold is the install wizard that's trying to do some things automatically. For instance, it has found out we're on Linux. It's found out that NGINX is installed. It found out that SSH is installed. So that also means that NGINX logs and SSH logs is installed, or they're added to the acquisition YAML file. Totally, it's set up. We have installed collection for, so we're able to parse NGINX logs and SSH logs, and everything works just like that. So that also means that later on in the workshop we'll be making sure that NGINX is in the acquisition YAML file. But if it has been auto detected, then it's already there. But we want to be sure, so that's why we tested. Once you have installed the CrowdSec agent, you should set up batch completion. Luckily, CSCLI supports that, so that's also pretty easy. And once you have installed it, you can test it out by typing sudo CSCLI and then pressing the tab button twice, as with any other batch completion thing, shell completion. Huh? What do? Sorry, I can hear you. No, you don't. No, you don't need batch completion for both VPSs, because that's you use batch completion with the CSCLI, and that's installed with the agent, which is only installed with Defender.
Can you generate a new one, because Python saying that this one is not working and we ran out of
Okay, that could be interesting. Which one is not working?
52, 28, 20.
Which number is that?
Oh, sorry.
Oh yeah, I can see that .0. Why is it called .0? That is weird.
Oh yeah.
Let me just something's probably wrong with the IP. I'll just log on. I find it. Malte, could you define not working, because I'm able to log into it? That's the.
Yeah. If you go into 52.20.22.
Well, I logged into using my backdoor account because I didn't want to do anything to his. Or to the default user, I mean. Yeah, well, if you can make him try again, then I'm watching the log. Yeah, sorry about that. I'll tell you in the meantime. I'll tell you a little bit about the CrowdSec Hub, because the CrowdSec Hub is a central repository for parsers and collections and bounces, and it's a bit like Ansible Galaxy or Docker Hub.
It's not working with the password and the user sorting around. It's not working on the
Okay.
So I use Workshop as a user and I put my screen as a password.
Yeah, probably. I've changed the password, so it's password with all small letters. Yeah, password is password, and small letters. All right. Right. Yes. As I said before, the CrowdSec Hub is a bit like Ansible Galaxy or the Docker Hub. It's we do accept community contributions because everything in the CrowdSec Hub is also it's a GitHub repo. So in reality, you just submit a PR to the hub, to the GitHub, to the repo. Sorry, the GitHub repo of the hub, and then when it gets accepted, then it also gets to be on the website or on the hub website itself. CSCLI is integrated with the CrowdSec Hub. So when you're downloading parsers and scenarios and collections with the CSCLI, you're actually interacting directly with the CrowdSec Hub. In terms of the CSCLI, it doesn't update install collection that parsers automatically. You have to do that. So there's a hub update and a hub upgrade command for that. People usually create a cron up to do it. And then in terms of managing collections is the example here, but it's the same commands that you're using for parsers and scenarios and stuff like that. So collection list all the collections that's installed. If you add a -a, then you have a list of all the collections that's available. Installing a collection is pretty straightforward. Installed, then a collection name. The same thing with upgrade. Upgrade -a upgrades FA all installed collections. As I said, it's the same thing for scenarios and parsers and post overflows and stuff like that. Another important thing you should know is a manual ban that's really good for testing. Where you can add an IP manually, and then you can verify whether it's actually blocked or not. And what is also quite common is that you need to unban something because either it's a false positive or you did something weird. First you list all the decisions, and then by CCLI decision list, and then you get a list of all the decisions that's being made with an ID, and then you just give that ID as an argument to the decision command, and then it's deleted. And there's a little error there because everything has to be sudoed, and else it won't work. But you'll find out pretty fast.
All of these commands interact with the agent, with the local installed agent.
Yeah.
And where does the agent store all of that? It's like a set of config files, roles.
By default, it's a what's called SQL. Well, I can't remember what it's called, the SQL fig that only does it that saves in flat files, but that's by default. But yes, SQLite, yeah, but it also supports Postgres and MySQL. If you, of course, that if you're running it more enterprisey, then SQLite won't work. Yeah, and if you want an overview of what your CrowdSec agent has been doing, try the CCLI metrics. That's the Prometheus thing that I talked about in the beginning. That will ask, or we query CrowdSec using Prometheus, and then get the stats from there. Before we are moving any further, we need to be sure that the NGINX collection is installed. So you do that by listing all installed collections, and if the NGINX collection is there, then it's fine. As I said in the beginning, that if it was auto-detected, then it is most likely there, but we need to be sure, else things won't work. And if it isn't installed, then you can install it. And also the HTTP CV, I don't know if it's installed by default, but if it isn't, you should install it, because as I said, it's a collection of of common web attacks that basically your CrowdSec instance will be sort of a honeypot for those for attacks. You don't have to be vulnerable to Log4j to be able to report it, luckily. So that's a good collection to have installed. And while you are doing that, I will do a little advertisement for another FOSS tool by our friends in a company called Punk Security in the UK. They have created Pwn Spoof, which creates a random log file with various attacks that's being used to test threat hunting and stuff like that, or for CTF scenarios or whatever they're using it for. We are using it to generate like a random log file that we then put into or ask CrowdSec to parse, because CrowdSec also have a possibility to parse offline or coded log files, as we call them, and that's a pretty cool feature. Testing. Pwn Spoof. Oh yeah, it is. It is a testing and training utility to create logs. Yeah. We are using it here because looking at a CrowdSec that has no attacks is really boring. So there's a possibility to log a code. So and the reason for that feature is to see what CrowdSec could have done. Well, to see, for instance, when Log4j came out, we had a scenario written for that pretty fast. But it would be great if you could see if somebody had been there before it was made public, for instance. Or you can also use it if you want to convince somebody that CrowdSec is a good tool, you could put all your log files to it, and then you can see what CrowdSec could have done if it was there. So yeah, it's a cool feature. So if you do that, run that line, then you will see something like that. Basically, for each line is an attack that's being detected in the log files. The only problem I have with pwn spoof is that it can generate more than just simple web attacks. I need to tell it to implement more advanced stuff, so CrowdSec can detect more advanced stuff. So it's mostly generic brute force attacks, stuff like that we detect. In reality, CrowdSec spins off a separate instance of CrowdSec. That's why we tell it to not run with, to not execute with an API. We're simply spinning up a separate instance that passes the log file and then shuts down again. So the one that's already running is not touched. All right. So yeah, let me know whenever that's being done.
I looked at the NGINX collection, which is installed here.
Yeah.
And it lists scenarios and other collections. I would have expected parsers in there because it knows how to parse the NGINX log file.
Yeah. The next parser is part of the collection, isn't it? It should.
Oh, yes, I just see.
Okay, cool. Right. Stop confusing me. Yeah, because obviously there needs to be a parser somewhere, right? Yeah. And once you have it running, please give me some kind of indication so I know that. Okay, cool. There's a few people who it works for. That's good. All right. We'll a little later after configuring in the NGINX and stuff like that. We'll be looking at at Metabase and the CrowdSec console, so you can actually see the attacks that we have just logged or loaded into CrowdSec. But first, this whole NGINX part. The way the workflow is like this: that we'll be setting up a Google reCAPTCHA session. You do that on Google's website, and you need a Google logon. And if you don't have a Google logon, then I have created keys that you can have. Then we're configuring the bouncers. We are making sure that the required scenarios are installed. Then we'll verify that the acquisition YAML is set up, and then we'll configure profiles YAML, because the way we will set this up is that we'll set up in profiles, the profiles YAML file, so that everything that's web-based will be handled by the NGINX bouncer, and everything not web-based will be handled by the firewall bouncer, which is the default bouncer. And last, we will verify everything works using an SSH brute force tool, where we will try and get the port scanning. Yeah, we'll try. Sorry, first we'll try with the SSH brute force to see that we can get that detected, and block with the firewall bouncer. And then afterwards we'll try Nikto, which is a very simple web scanning tool, and to see if the NGINX bouncer works as well. Good. All right. As I said, a Google account is needed. You need to go to google.com/reCAPTCHA/admin/create. And as I said, if you don't have one, then let me know.
The guest Wi-Fi should work, by the way. Should work to go to the guest Wi-Fi. That's the issue.
So the way you should set up reCAPTCHA is that, unfortunately, reCAPTCHA version 3 is not supported, so I have to select version 2. I usually choose the I'm not a robot, even though I have a hard time understanding why it works, but maybe that's just me. And then the CrowdSec workshop, the domain you're using is CrowdSec workshop.xyz. It's a totally legit domain that I bought. And then accept the terms of service, and then you're good to go. then after that, you will be getting like a side key and a secret key, which you will need to put in the bouncer configuration file. And once you've done that, look into the CrowdSec NGINX bouncer conf file, where you will be pasting those two keys in, and also change. There's a line called mode, and by default it's mode equal live. That means that every time there is an IP coming in the bouncer, CrowdSec will check it right away, and that's good, of course, but it doesn't scale very well. So if you do it stream, then it will check like every 20 seconds instead, and it won't kill your server, which is a good thing. Right. Which medium do I get them? Do you get them? I guess I could. Hang on a second. I'll just put it there. You should have a rectangle keys that text where the keys hopefully are.
Yeah.
Good. Then I selected the right VPS, which is good. And then after editing the bouncer conf, you need to restart NGINX. To verify that you have the NGINX log in your acquisition YAML file, yeah, open it and see. And what I've added there is the latest version of what the wizard installed, of what the wizard's installed itself. Apparently I thought it was too hard to write two lines where one is access.log and error.log. I just wanted to parse all log files. And of course, if you have those two lines instead, that works equally fine. And the chances are that you have it. The way the profiles YAML file works is that it's this file that decides, or the configuration in this file that decides what happened when a given scenario is triggered. For instance, how long time are you banned? What is happening? Ban is default, but capture is another option. Also, the scope of the remediation, because as I said in the very beginning, CrowdSec is able to take deviations of any kind. So that also means that IP is just one of the data it could look at. It could look at everything. So, but by default, of course, we're using it for IP, so that's the default. But it is possible to do other things with CrowdSec. And also, you can enable or disable debug for a specific profile. And also, you will also decide in the profile YAML file which scenarios are being triggered. You can write many instances. Like if you want a particular thing to happen for each scenario, you can do that. If you really want to have a long and complex profile YAML file, no problem. This is the default file where it looks at possible to not remediate a scenario, and that might sound weird, but maybe you just want an alert. Maybe there is no remediation. Maybe, for instance, we have a scenario that detects whether a given exploit has been run, but we can't really do anything about it if it is. So there's no need to do anything. Of course, the bouncer should only do anything if we want something to happen in the scenario. And also if it's an IP. If something needs to happen and it's an IP, then IPs are being banned for 4 hours. That's the default. But the new configuration is where we'll set in the whole capture remediation thing first before this default thing, and we'll leave the default thing, or leave what I just talked about before. And we want to remediate all scenarios starting with CrowdSec HTTP, with the captcha, with the NGINX bouncer, and everything else we want it blocked by the firewall bouncer. And this is how it looks like. The whole red part, that's what's there already. So the green part is what you're pasting in front of the red part. And if you get weird errors, then remember this is YAML. And YAML is notorious for giving weird error messages that doesn't make sense. If you forget a space, or you just type 2 hyphens instead of 3 as a separator, then it's mad. And that's probably what's wrong if it complains. And once you've done that, reload CrowdSec. Now we're almost there. So that's good. Because now it's time for the fun part, which is of course the hacking thing, if you can call it that. But let me know when you're ready for that. Good. Yeah, well, if you are ready, then you should log into the defender and tail the CrowdSec lock. And then afterwards, log into the attacker and then initiate the attacks. The bad part about this is, of course, that it actually blocks the attacker. So you will need to unban it. But yeah, I completely forgot to write that in the slides, but that's pretty easy. You need to look at the CSCLI decisions command, where you can list decisions and then delete decisions, the decision that blocks the attacker IP from the SSH brute force attack. If you delete that decision, then the attacker is able to connect again. And let me know if you need help on that. And also, it's important not to do this from your own computer, because then you will be blocked, and that's bad. Yeah, exactly. Then all of you will be blocked. I dare you. And also, I can't help either. No, I'll just access it with something else.
Do you have any way of mapping to mapped IP addresses? So, for instance, university IP address, or as like an IP range of 10 IP addresses, malicious students doing malicious things, blocking the whole university access?
No.
Okay, so it is on IP level.
Yeah, because the only thing that's being oh yeah, I thought I had a slide about that. But the only thing that's being sent to CrowdSec is the source IP, is a timestamp, and the name of the scenario that's being triggered. That's the only data we collect. So it is the only data we have from the attacker. We don't know who's behind that net gateway or whatever.
Okay, you can't do any header injections to determine the session of a specific IP.
We probably could, but we don't. because it's by design that we're collecting as little as we possibly can, privacy wise.
Sorry, I'm not a security person. Can you say a few words about Hydra?
Yeah, Hydra is a brute forcing tool. It can be used to brute force a number of protocols. SSH is one of them, VNC, SMB, stuff like that. And you could do it in many ways. The way we're using here is to take a word list that's being installed by default by Kali, and then use that. But it can do much more advanced stuff than this. I just wanted to do something, so I haven't been fiddling much with the arguments. But yeah, it's a brute forcer.
And that all runs on the attacker machine that we just looked at.
Yes.
That machine issues HTTP requests as opposed to our defender.
Well, not on that. It tries to brute force using SSH.
Oh, SSH. Oh,
yeah. But yeah, it could be anything else. And when you need to unban yourself, I had something about it where here. Yeah, here. Unban, CSCLI decision list, and then you get a list of all the decisions, all the bans that are, and you just delete the last one, and then you're able to do the other attack. Again here, because it's a little bit more complex to test this whole captcha thing, because one thing is to see in the log that something is happening, but we also want that captcha thing in our browser, right? But in order for that to happen, we need to trick the VPS that have CrowdSec installed to think that we're coming from the attacker. And the way we're doing that is a little thing called SSH. That what we will be doing is that we'll be logging into the attacker. Then from the attacker, we'll be setting up another SSH connection to localhost. And while doing that, we'll be setting up an SSH tunnel that forwards all traffic from port 8080 on the attacker to the defender on port 80. So that means that once we have that SSH tunnel set up in your browser on your computer here, you will connect to the attacker on port 8080, and it will be forwarded to the defender on port 80. So the defender thinks you're coming from the attacker, and you will see that nice captcha thing. Right? Make sense? Maybe it does. Well, for the record, SSH tunnel, they can do a lot of crazy stuff. This is only, yeah, the surface. And when you're connecting to the attacker on port 8080, you need to use the DNS entry that is in the DIP list. And of course, you won't be writing attacker XX, you will be writing attacker 03 if yours are number 3.
You have the default profile somewhere.
So you delete yours.
Well, the service was crashing, and so it might have been a change to the profile file.
Well, it's in the slides. It's in the slides.
Yeah, but that's not working.
Oh.
If I delete everything and I open insert the stuff in the slide, it's not working.
Or it could be. But yours was number 19, right?
Mine was number.
All right, I'll see if I can figure out what happened.
Mine is 111.
Yeah. Well, can you see anything in the CrowdSec in the agent log?
In the channel?
In the var log CrowdSec log file?
There's no CrowdSec folder.
Oh yeah. Now I see what you did. You added the NGINX thing from my slides, even though it wasn't necessary, and also then messed up the format because each type only has one label.
Okay.
So it should work now.
Yeah.
How to go to
Sorry, that's what?
it's how to go to version and
On web scans?
and
Oh, Nmap. Yes, there is a CrowdSec collection for port scannings as well.
so if I do an end scanning against SSH memory stuff, it will also alert.
Yes and no. The reason why I say no is because by default, port scannings are not logged by IP tables. But if you set up a logging rule, yes. Yeah.
This is called by the firewall bouncer that we installed.
Yeah, it is.
Because it has nothing to do with the NGINX. I suppose.
Yeah, exactly. That is the only way we can block it.
So the firewall bouncer somehow scans the SSH authentication mode.
No. The agent is taking the attacks, and the agent determines your IP should be banned. Then the bouncer asks the agent, should I block this IP? Yes.
And what else does the firewall bouncer secure? What else does it protect? It protects SSH attack.
Well, the firewall bouncer is the default bouncer, so it can block anything. And depending on what you want to do, it's always cheapest to bounce on the firewall level, of course. But the downside with using the firewall bouncer is that there is little room for false positives, because if you're blocked, you're blocked. You don't have a way around it as you have with the bouncer. Oh, sorry, with the next bouncer and capture. So that's the idea.
So would it catch normal TCP/IP connections, for example?
The firewall bouncer?
Yes.
Yeah, the firewall bouncer can block everything that a host firewall can block, that IP tables can block, and that's yeah. It hooks into IP tables, so it uses IP tables command. Basically, it creates a separate IP table chain that it adds IPs into, and then they're being blocked by IP tables. So that is another point with CrowdSec, is that we don't want to reinvent the wheel, right? We want to use things that are already out there and make them a little bit better. For instance, there's also a parser and scenarios for Suricata IDS, so that every time Suricata detects IPs that should be blocked, they're based by criticality. So by default, this scenario blocks everything that's high or critical. So in that way, we put an extra layer on Suricata, so it's crowd aware. That if you have CrowdSec on all your parameter firewalls and one of them are detecting malicious traffic by Suricata, then it would block all of them, like that. And the same thing with mod security. There's also parsers for mod security, and we're working on other WAFs as well.
Yeah, it doesn't work with my machine. I can still log in from the attacker and the defender IP.
When you looked at green and red, the YAML type, you delete the red.
Yeah, that's the problem.
That's not how we're putting on.
Yeah. So yeah, I can see that. I should probably choose another color. Yeah.
The green is for the capture and the red is for the
But I can't see why I should maybe choose another color.
Installing the database dashboard, I get an HTTP error, permission denied message, metadata data, CrowdSec DB, permission denied.
Yes. Look at the next slide. Because our new version was literally just released today, and they literally screwed up that part. So we need to do a few things for it to work.
You mean on the self-hosted metadata slide? There is up install open and IP with something.
No, hang on a second. It's this slide. Yeah, it's a slide that I'm showing now. You don't have that slide? Oh, sorry. Yeah, now I. Oh, yeah. Now I know. Now I know why. Now I know why. Sorry. Yeah. Oh well. Because I forgot that I created a separate copy of the slide, and I didn't change. I didn't update the bit.ly thing. Oh yeah. I'll have a new shortcut for that. Sorry? Yeah. Yeah. banned by the firewall bouncer, and then the next bouncer won't see you. All right, I updated the bit.ly thing, and where the hell is it now? Oh yeah, I created a bit.ly thing for these slides. You'll see the address on the slides now. So CNCF-slides. All right. So the next part is installing the dashboard, the Metabase dashboard, and it will take a little while. And it also complains about not having RAM and a lot of weird stuff. But just ignore that and go grab a beer or whatever, or a pizza. Has anyone not done the whole Metabase thing? All right, then I will forward. Okay, and yeah, and once Metabase is installed, you open you go to the IP of your Defender :3000 port 3000 in your browser, not SSH, sorry, not SSL, just HTTP, and then use the credentials that Metabase gave you during the install, and then you can log in and see all the results from spoof log. It looks a bit like that. Then, in terms of the CrowdSec console, you first need to create yourself a user at app.crowdsec.net, and once you've done that, you should log in and click the Add Instance button, and then you will have like an enroll string here. That's that you need to paste in the CCLI on the Defender, and then back in the console, you will have a pop-up that looks a bit like this, and accept that, and then you're good to go. I think maybe you need to restart the CrowdSec agent, but it will tell you that you need to do that. And then it will start sync log. And then I thought I want to show you how mine looks. Pardon?
What slide number are you?
That's slide 52. But obviously this is not a slide. This is the general. What the hell is that? I don't know why I log into that.
Okay.
All right, good.
Oh shit. I checked if that is logged or not. I deleted all decisions and going to the FQDN :8080 times out of this machine.
Okay. Well, first try and connect directly to the Defender on port 80, because if that doesn't work, then NGINX is not running. Or it could be like the firewall block that's from the SSH attacks that can be screwing with you. All right, these are my instances that I have in the console. I have a Debian server, a FreeBSD server. I even have Windows. I have a Raspberry Pi. I have 2 OpenSense firewalls, and I also have a VPS that's running NGINX Proxy Manager. And if you want to see an overview of of the attacks that's going on my servers, then the console can show you that. It can tell you which IPs they are, where they're from. China, what a surprise! But Microsoft's there. Oh, Microsoft in Brazil, Linode, Poland, UK. So, and the country-wise, the US and Russia and China and Brazil. But I think the most interesting here is is to see the attack types or the scenarios, because you can see by far that the SSH brute force is the one that's being most attacked. But that's also because, as you saw when we installed CrowdSec, if you have SSH installed on Linux, and you have, then CrowdSec will install everything for you. So it's and since that CrowdSec was just until recently only available on Linux, there is a large percentage of the attacks of the signals that we're getting that are SSH brute force attacks, because we have simply so many agents with that scenario installed. And a few are like Fortinet CVE. That's in the HTTP CVE collection that I talked about a few times. So yeah, but if you go to the top, then there is because most of the attacks that you see here are background noise. That's brute force attacks for very simple passwords that only exist on that crappy IoT device or whatever. So if you have just somehow a normal security, then you wouldn't be hit by this anyway. So a relatively new feature is canceling that away, like noise canceling, because it's noise. So if it's noise, we don't want to look at it. So it's there's some AI stuff, some fancy AI stuff that I don't know anything about, that figures out what is noise and what's not. And if we enable that, then the noise is gone. In terms of the CTI functions in CrowdSec, you can click on an IP here, and then if that works, and then watch that IP, and then you will see what does the crowd know about that IP, and which kind of attacks is it doing, how long time have we known it, how aggressive is it, and stuff like that. And this is actually a little bit uncommon, because most of the attacks that we see, or the IPs that we have, are new IPs that just entered the database recently, and they won't be around for long, because the attackers are always trying to find new vulnerable servers out there to hack, so that they can remain anonymous. They don't want anybody to know where they're really from, so they're hacking VPS around the world or servers to sort of hide their own identity, or their real identity, of course.
Classification of an attack, for example, you make a specific detection of an attack, and it's a slow kind, so it's trying to exhaust resources on the server. Who does that?
Who does what? Sorry?
The classification of the type of attack, because you can.
Like here. These are scenario names. So the classification is the scenario name. Okay. So that's why the downside to that is that it's removed by noise cancelling. But if I had disabled that, then you could see that on these there is also no, maybe not. But anyway, I used to have on my Raspberry Pi, I installed an SSH tar pit called Endless SSH, and the tar pit, the only thing it does is to not time out. It gives a connection so slow that basically we are trying to waste the bad guy's time, and that's good, of course. I used to have a lot of attacks on the Raspberry Pi that was SSH, but since the scenario is called something else, it's not categorized as an SSH brute force because it's in SSH. It's a different scenario. So even though it's the same attack, it's still not categorized in the same way. So there is.
Do you define it? I mean, me as an employee of a company, or does CrowdSec define that?
Who defines the scenarios? That is part of the hub and in GitHub. So when you are writing, or if we say you want to support, I don't know, Mailcow, just to say something, then you're probably writing a parser. You're probably also writing a scenario, and you're submitting it to the hub as a PR, and then you're deciding the name of the scenario. But there are certain restrictions because it has to be under your GitHub username. But apart from that, there is no real strict no real strict naming convention. Yeah, and Jesus Christ, that wasn't my. Where is my? Yeah, I wanted to show you something because that was my personal account, but since I'm CrowdSec, of course, I have an enterprise account, and we have sort of fancy things there as well. So these are honeypots. It's not all of honeypots, but I have some of them assigned to this account. And if you look at the alerts that we are seeing, it's a lot different. For instance, you will always see OpenZips, and that is zip, that is a voice over IP, because that is by far the scenario that has the most signals per agent. SSH is zip is being hammered constantly, all the freaking time. So 86% of these are zip brute forces. I don't know. Maybe my latest theory is that they use them for robocalls, automated phone calls.
That makes sense. I mean, robocalls is such a big problem in the US.
Yeah.
People start stopping using the phone because of the amount of robocall. Huge problems in the US.
So yeah, and there's a few SMB brute force because somebody scans for SMB brute force apparently.
Yeah.
So we can filter for that scenario and then see who are doing these kind of attacks. That's actually a wide variety of bad guys doing this. These are just SMB brute forces, right? So we could do the same and try and look up like this IP, for instance. This is the one that's doing the most. SMB brute force, RDP brute force. Yeah, this is very new. Well, there was something in September, but maybe that's from another hack of the VPS. Because I do a talk on Log4j as well, and that talk I have statistics on the different cloud providers in terms of how good they are at cleaning up. Because once our database, it's been compromised, and once it exits, it's being cleaned up by the provider, right? So in that time, that's an average or days or hours or whatever. If you take the average of that per ASN, then we have an idea of how good that provider is at cleaning up.
But how do you know that it's now clean?
Because it goes out of the database. Because the thing is that CrowdSec IPs are only on the block list for 72 hours. Then it needs to be refreshed. Huh?
That's maximum counts.
That is the maximum. That's the maximum time it can be in order to, if it's not refreshed.
Okay.
So it has to be resubmitted to stay.
So when the attacker is quiet for 4 days,
then they're gone at least on the block list. They're still available in the signal database because we know they used to be bad and stuff like that. But we are taking into consideration that IPs on the internet, that they are volatile. They're changing all the time, so it doesn't make sense to keep an IP in the block list, because who knows what happens tomorrow on that IP. So yeah, so this is most likely from another attack of the same IP, whatever had that IP at that time. But there is like 80% of the IPs that we have on the block list are IPs that has been there since day one. Believe it or not. So that means that there are a number of providers out there who don't give a shit.
How much percent?
80.
80?
80. And the rest are IPs that are in there for a week, then out again. And of course, there are also a few in between, but that's the main groups we are.
How much of the internet of the IPv4 range
is shit? No, I
already
no. That's a good question, because I don't really know, but also because a lot of things has happened in terms of widespread adoption in the last 6 months. But I mean, it's an exponential curve. So what we had like half a year ago, it was a fraction of what we have now. So we don't have that much.
And how do you deal with IPv6?
I should be. It's really an issue yet, so we haven't really discussed it yet, I guess.
Okay.
So, but somebody else. Yeah, I know. Sorry, I don't know it's, but that doesn't mean that nobody knows. But we are dealing with IPv6. The CrowdSec for CrowdSec is just an IP.
You also remove it from the block list after 4 days.
IPv6, yeah. As far as I know, it's the same. But what I wanted to show you was our this is our data lake, because I have login. So we can actually see real time what we have, but how many signals we have, for instance. It takes a little time. There are a number of millions signals.
Oh, nice.
So over time we have well, internally a Pokemon is a bad guy. So over time we have collected more than 12 million of those over time. Of course, they're not 100. There's not 12 million on the block list now, because the block list is not that big. We collect around 20 million signals a day. We have around 11 million signals in the smoke database, but the block list is only 26,000 IPs. So they're being heavily refined. We are very conservative before we put an IP in the fire database or in the block list. Still waiting for that. Oh, that is bad. So that is the top Pokemon. Yeah. Fly services and OVH. Yeah.
So much OVH.
Yeah, and on the statistics that I talked about before, in terms of how good they are cleaning up. On average, AWS they take 3 days, but OVH are 17. 17 days.
And there's heads now.
I don't know, but because as I said, these statistics are a little bit old. We only did it for a report that we did like almost a year ago, and there weren't that much going on a year ago. But we are creating like a real time thing where for each ASN we can see statistics, but I don't know where heads now are.
Sorry, CrowdSec is a French company, right?
Yeah.
But isn't that, I mean, OVH is French, so is that the reason why OVH is that top in the list? First, you became bigger in France.
Yeah, that's probably it, because we need to have sufficient signals originated from that ASN before we can say anything meaningful about it. This is an interesting graph, because that tells us how many signals we are getting, and those are two different graphs. The red thing that corresponds to the write 450,000. But on the left, you have 24 million, stuff like that. Those are the bars. Those are the signals that we get. So you can see what happens at some point. Something weird happened, and what happened around in the mid-September was that we talked to a company called GetShield. They are doing WordPress security, and they want to collaborate. They want to use the CrowdSec mechanism in order to distribute information about WordPress vulnerabilities within themselves. So around in the mid-September, they finalized implementing CrowdSec support in their agent, and they started rolling it out. So what we got exploded, or the signals that we're getting, they see the huge spike or the huge growth there. They are basically WordPress. but it looks a little bit crazy, right? So yeah. Let's see if that's not so interesting. Those were just signals. Maybe we could look at the installations and see how many. Last time I looked, we had the CrowdSec was around in 172 countries. Maybe it's a little bit more now. I don't know.
Do you also separate or take into consideration that IPs are consumer IPs, like when you're having an IP or from a carrier grade NAT pool, IP pool from, I don't know, hier in Austria 3, A1, yeah, and also business ASNs.
As far as I know, we don't look so much at that. I mean, I don't know about the pre-crime thing that tries to do stuff with IPs before they're really banned, if they take it into consideration. But an IP is just an IP, okay. You know. So we're on the 173 countries, and we have 60. That's I think that's agents, unique IPs. So yeah, we are a lot of OVH. Mm-hmm. But yeah, I don't look at these data every day, so I'm not that comfortable in finding all the good stuff in it. But that was more or less it. Just remember that CrowdSec is not just fail to ban. You can install your WordPress site. We of course do that before the WordPress plugin. Any website behind a reverse proxy, or even your Nextcloud instance, because everybody loves Nextcloud. And you can also set CrowdSec up as a sort of canary device on your internal network, so it reacts on port scans and DNS lookups, things that don't normally happen on your network, if you are the paranoid type or you just have a very large network.
And how do you, because as far as the command line tool, I mean, it's installed locally and interacting locally with the...
By default, it's installed locally, but you can install it anywhere, and then connect and then configure to talk to the local API.
Perfect. And that's how you manage remote hosts, or how do you manage remote hosts?
Yeah, that is one way of doing it, or you do it with Ansible, or depending on what you want to do. We don't have any good fleet management tools yet, but we do have large installations, and I don't know how they do it because I haven't been involved in that. And I have been involved in that. And if you want to have a little bit more fun, then you can install the invulnerable web application DVWA and run it in Docker on the port 5000, have it running there, and then CrowdSec supports Docker logs as a data source, so you can just configure to hook directly to the Docker daemon and get logs there, and then in the same way as you did with Nick, to see if you can detect attacks in the DVWA container for fun. And we have a Discord community, and if you scan the QR code, then you can join. it's mostly a support community, but we want to have it to be a more sustainable community. We want the community to grow, because the problem with the support community is that people are there for support and then they leave. We want them to hang around. Yeah, and find us on Twitter, or we're not on Mastodon yet. But the problem is that I'm a marketing person, sorry. The other marketing person don't really understand Mastodon, and I don't even yet, because I just joined last week, as everyone else did. Yeah, and find me on LinkedIn or send me a mail or whatever. I'm around. Well, thanks for wanting to be here and spend time with me on this evening, and thanks to Malte for hosting, of course.